Hey everybody, welcome to the second video on the unit involving square roots and the Pythagorean theorem. This video is going to be about prime factorization, what it is, what it means, and how do we do it. Okay, so first of all, what is the big picture? Why are we doing this? What it's all about? What do we need to know? If you have the document already, these notes are already in there. If not, it's perfectly fine to just read them up on the screen. You might not understand all of this right away. It's okay. Come back to it later. Just confirm that, yeah, I get it now. All right. Some of this you should also know. So a factor is an integer that when multiplied by another factor results in a given number. Okay. So you just multiply two things together to get something else. That's what a factor is. So 2 and 5 are factors of 10 because 2 times 5 is 10. All right. Numbers with only two factors are called prime numbers. So when you only have two factors, two possibilities, then that is now a prime number. So is 6 a prime number? The answer is no, because you can do 1 times 6, you can do 2 times 3. That's 4 factors, not 2. How about 3? 3 is a prime number because you can do 1 times 3 and that's it. All right, moving on now. Numbers with more than two factors are called composite numbers. So 6, for example, would have been a composite number. Numbers with an odd number of factors are called perfect square numbers. That's interesting. So if you have a number like 4, which we saw in the previous video was a perfect square. Well, you have 1 times 4. Those are two factors. And then you have 2 times 2. So that's 3. That's an odd number. So that is an odd number of factors, and that results in a perfect square number. Prime numbers are the numbers all numbers decompose to prime numbers. And what that means is you can take a big number and you can break it down into smaller bits, and those smaller bits, if they're prime, they'll all multiply together to get that big number all over again. So that's mostly what we're going to be looking at in this video. Okay? And a number that has pairs of equal prime numbers is a perfect square number. So what's the next step? Well, we're going to use our knowledge of factors and prime numbers to write a number as a product of its prime factors. You don't have to understand all this language right away. Basically, what I'm saying is we're going to break down big numbers into smaller numbers and show that they are the same. Okay? And in other words, that means we're going to prime factorize. That's what that means. There's two methods we're going to look at. There's the factor tree method and the repeat division method. Both of them are perfectly fine. Both of them work well. The factor tree is my favorite because I get to draw a tree, and I'm not an artist, so that's like the closest thing that I get to real art. And the division method is also really good because it takes a lot less space. But they both work perfectly fine. You can use either one in any situation. They don't really function all that differently. Let's start off with a factor tree. It's a diagram used to break down a number by dividing it by its factors until all the numbers left are prime. And what I'll say here is the major difference between a factor tree and the divisor is that you can break a factor tree down into any of the bits that you know. So for example here, you look at 48. 48, yes, you can do 1 times 48. You can do 2 times 24. But I also know that you can do 6 times 8. So I'm breaking this 48 down into two branches. And the branches go to 6 and 8 because 6 times 8 is 48. Okay? And you'll see how that's different in the next thing, because in the next one, you're only using the prime ones to break it down. So it can be a little more tedious sometimes. I like the fluidity of this. But let's see how it works. So 48, you break that down into 6 times 8. And you should agree that 6 times 8 is equal to 48. Now we look at this branch, 6. Can 6 be broken down? Well, yes, it can. It can be broken down into 2 times 3. And the reason that these are circled is because they are prime numbers. You can't break them down further. Like, what's the point of saying 1 times 2? Oh, and then I can do it again. 1 times 2. And no, that's just stupid. When you get to the prime number, you stop and you circle it. And we circle it so that we keep track of them. So we have 2, 3, Now we can look at the other branch, because this one is full of circles. There's nowhere else for it to go. This one dropped down to 8. 8 can be broken down in a number of ways. 4 times 2, 2 times 4. Doesn't really matter which way I go, so I do 2 times 4. 2 is done, so I circle it, and I look at the 4. 4 can still be broken down to 2 times 2, and that's where all these numbers at the bottom come from. So we have 48 is equal to, so this 48 is equal to 2 times 3 times 2 times 2 times 2, or if I arrange them from smallest to largest, which helps keep track of the order, 2 times 2 times 2 times 2, and 3. Okay? All right. Let's try the division or the divisor method. So I have some lines here, and I'll kind of go through what that is. You start off with a number like 72. Let's just pretend that none of the rest of this exists. All you see is the 72 on your screen. What you want to do for this is first you want to look at that 72 and figure out what the smallest prime number is that you could divide into it. So the prime numbers you should know are 2, 3, 5, 7, and it does continue on. You have a few more like 11 and so on, but you won't use them quite as often. Those ones you can just test along the way. Usually 2s and 3s and 5s are going to be the ones that you're going to encounter the most. So use the smallest prime number to divide that. So I go like this. 72 divided by 2. Well, 72 divided by 2 is 36. So I write 36 down here. Now I do 36. 36 divided by 2. 2 again. Okay? And 36 divided by 2, that's 18. Now I look at the 18. 18 divided by 2 is 9. Now I look at the 9. 9 divided by 2, no, I can't do that. So 9 divided by 3, yes, I can do that. 9 divided by 3 is 3. Now I look at the 3. 3 divided by 2, nope, can't do that. 3 divided by 3, yes, I can. It's 3. And I'm left with 1. When you get to that 1, then that is where you stop. Okay? So you stop here. And we kind of just ignore that 1. We just pretend it doesn't exist. So you have all this stuff here. And what's really important are these numbers here. These are basically the same as those leaves on the branches that we circled here. So all this, 2, 2, 2, 3, 3, they can all be multiplied together to get that big number of 72. 2 times 2 times 2 times 3 is 72. And if you don't believe me, use a calculator, but I'm not going to waste your time to do that. Move forward. Prime factorizing using the following numbers. So we're going to try both methods here. And I'm going to go a little faster so this video isn't taking too long. We're already about 8 minutes and it's longer than I want to be already. So let's try with the divisor method first. So I look at these and I remember that I'm looking at 2, 3, 5, 7, and so on. 2, no, not going to happen. 3 could happen, but 5 is an easy number. Let's go with that. So let's do 5 because I can definitely divide 625 by 5. And I will get 125. Hey, look, that one ends with a 5 again, so let's do it again. Divide by 5. Well, if I divide that by 5, I'm going to get 25. Yeah. And that's a more familiar number. I don't need a calculator anymore. 25 divided by 5? Absolutely. That is 5. And 5 divided by 5? Absolutely. That is 5. So 625 is the same as 5 times 5 times 5 times 5. All right. This one right here is kind of a tricky one. I'm going to try to trick you a little bit. Let's see if we can use the tree here. Normally, I would use the tree because I have numbers that I know I can split up pretty easily and make it grow evenly. So my use of a tree here is actually kind of dumb. I would normally use it for like 625 or 240, where I know I can divide this by 10 for sure. I can divide that by maybe 25 for sure. But this one, let's try it. Let's see what happens. 426. So what I could do if I have a big number like that, 426, is I could test some stuff. I don't have to just use the smallest number. I could divide by 12. Oh, it's a decimal. That means I cannot divide it by that number. How about 14? Can I do that? No, I cannot. How about 10? No, absolutely not. 8? Oh, that was weird. I didn't click the divide. 8? Nope, doesn't work. So I guess I'm going to go with something safe here. I know for sure I can divide by 2. 213 is what I get. So I divide by 2, and I get 213. 2 is at the end of its rope here, so I circle it. 213. Well, that has to be divisible by something, right? So is it divide? Can I divide by 2? No. Can I divide it by 3? Let's try it. Oh, yes, I can. So I divide that by 3. 3 is at the end here too, and I get 71. Now let's look at that 71. That's 71. Can I divide it by 2 just by looking at it? No. Definitely not. 3? Possibly. Nope. Looks like I can't do 3. How about 5? No, I can't do 5. It's not a 5 or 0 at the last number. How about 7? Possibly. Let's try that. Looks like a no. How about 71 divided by 11? No. How about 71 divided by 13? No. Now we're getting to some unfamiliar primes, ones that you don't usually use very much. And what you'll actually find out is 71 is a prime number. The only things that you can divide that by are 1 and 71. So 426, and that's why I said it's kind of a trick question at the beginning, the prime factors are 2, 3, and 71. Yeah, it's kind of weird, right? But that's what it breaks down to. And sometimes you might have a prime number that's really big, and you'll only know after you have tested all the primes that you know, and hopefully get past there at that point. But you usually won't get those kind because that's really tricky. But it's good to know. Let's try a tree method with 240, just because I didn't really get to do my tree for the other one. So 240, I'm looking at that. I have a 0 at the end. I know I can divide by a nice number like 10. But I also see that it's an even, like it's 40, right? So I know I can also definitely divide by 20. Let's just do that. 20. So what is 240 divided by 20? Well, that is 12. All right, so we split our branches really nicely here. We can break up the 20 now. 20 can be split into 2 and 10. The 10 can be split into 2 and 5, and now we have those branches all finished off. The 12 can be split into 3 times 4. 3 is prime, and the 4 is 2 and 2. So if I'm rewriting the 240, I have a little more room down here, so I'll write that here. 240 is equal to 2 times 2 times 2 times 2, so that's 4 2's. Then times 3 and times 5, and I have them all. So that would be my answer for this one. Okay, and just to wrap this up, here's a quick show you know. I want you to try what we just did with whatever tree or divisor method you want to use. Go with whichever one, but try to use each one at least once just for the practice. Do all 3 of these, pause the video now, and then come back and check your answer. Okay, so you have unpaused, I'm guessing, assuming you did the work, and here are the answers. So here's what I got. For 144, I got 2 times 2 times 2 times 2 times 3 times 3. 4 2's and 2 3's. For 4,900, I broke that down to 2 times 2 times 5 times 5 times 7 times 7. And for 11,025, I broke that down to 335577. That is the final one, so I hope that was helpful.